Hello, welcome to today's class. Today I am going to teach the basics of DFA, that is deterministic finite automata. So, in today's class, we will see what exactly is deterministic finite automata, which stands for DFA. So now, when we are discussing about DFA, the basic definition that we are going to give is a DFA is a five-tuple automata or a quintuple automata. It is one and the same. You can call it as five-tuple or quintuple. So, what do you mean by quintuple? Quintuple indicates it has five values in it. So what are the five values? Let us consider the automata machine is called as M, and here in this we are going to have five different units. So that's why it is called as quintuple, wherein the first value will be Q, the second value will be summation, the third value is delta, which stands for transition, and next value is Q naught, and the last value is F. So these are the five values we have in finite automata, in which let us define each and everything in detail. M stands for a machine, or it is a finite automata. You can call it as a automata. So M stands for that. Next, what we have is Q. Q stands for the set of states. We'll say Q is set of states. And then we have summation, which stands for set of alphabets. Set of alphabets. And whenever I am saying alphabets, alphabets in finite automata can be from 0 to 9, or it can be A to Z, or capital A to Z, and special characters. And then what we have is summation. Summation is always defined as the transition which indicates the transition over, which indicates transition is defined as it is the states that we have over the alphabet that we are going to take and the new state that you are going to get as a result. So this is how we are going to write a transition. Let us see some example to it. What is the example? Transition from state Q naught over a symbol A will gives you Q1. This is an example for a transition. So after this, we have Q naught, where Q naught is nothing but the start state of the automata, and F is nothing but it is the set of final states. It is the set of final states. So this is how we are going to define DFA, that is deterministic finite automata, in which first one is set of states, summation is set of alphabets, delta is the transition that I have given an example here for delta, and Q naught is the start state, F is a set of final states. So this is how we are going to define. Now let us see an example for this. So the example, I will take a normal simple finite automata. Let us try to define each and every state in it. So what I am going to do is, I will just write a transition diagram in which, see, I have written a state which is called Q naught, and I have given an arrow, starting arrow, which indicates Q naught is the starting state of my finite automata. Next, from Q naught, I would like to go to state Q1 with the transition by taking an input symbol A. So, this is what I am going to call as a transition. Now the number of states I have in my finite automata is Q0 and Q1. So finally what I am going to do is from Q1 I'll take B as an input symbol. I'll take B as an input symbol and I'll go to Q2. Here what I do, I'll enclose this state with double circle which indicates it is a final state. And here I'll write one more transition which is nothing but a self loop which is A comma B. So this is the basic finite automata which I have taken for an example. Now in these finite automata, let us see what are the transitions we have and what are the 5 different values we have in this particular diagram. Now as per the definition that I have given, what it says, M is equal to Q summation delta Q naught and F, right? So here what is Q? Q is nothing but the set of states we have, Q0, Q1 and Q2. So here we get Q0, Q1 and Q2 are the set of states. Then second thing we have is alphabet. So here what are the alphabets that I am using? You can see here you have A, here you have B, here you have A and B. So the set of alphabets that I am using in this particular DFA is A and B are the set of alphabets, and third one, transition, I will define in some time, that is in the next page I am going to define, or here only I will define it. Next, Q naught is nothing but the start state that we have in the diagram. And what is F? F stands for the final state. What is the final state in my diagram? Q2 is the final state that we have in this particular finite automata. Now we have seen what are the set of states we have, Q0, Q1, Q2. Set of alphabets we have is A, B. Q0 is the start state and Q2 is the final state. I think you guys are clear with respect to these 4 elements. Now let us go to very important thing, that is transition. So let me define transition here. If you have understood all these things, I'll just make some space for writing the transition. So what I am going to do now is I am going to tell you what exactly the transition indicates. Now see, what are the transitions we have in the overall diagram? If I want to go from state Q0 to Q1, I want to read the input A. If I want to go from state Q1 to Q2, I want to read the input alphabet B. Similarly, if I want to go from Q2 to Q2, I want to read the transition or the input A or B. When I am writing A comma B, it indicates A or B. Okay. So now, how I am going to represent it? See, transition from where? Q to Q0. What is the input symbol I have? A. From Q0, if I read A, I am going where? Q1. That is how you are going to represent a transition. Next, suppose I am in the state Q1. Here, I am going to read the symbol B. So from here, I am going to a state called Q2. So this is one transition. Now we have 2 more transition, one transition for A and the other transition for B. Now let us try to read it. Transition from Q2, if I read A, where I will go? To Q2. Transition from Q2, if I read B, where will I go? To Q2. So totally we have 4 transition in the diagram. Now, the same transitions that I have written here can be represented in terms of a table which is called transition table. So let us try to see how I am going to write a transition table. Now, see, transition symbol I will take, and here what are the alphabets I have in the diagram? I have A, and what is the second alphabet I have? B is the second input or the alphabet. What are the states we have? Q0 is the state I'll take a start symbol to it. Q1 is another state and Q2 is the final state, right? So three states, and you can see how I am going to differentiate between the states here. If it is a start state, I should give arrow symbol. If it is a final state, I should give star symbol. If it is any normal state, I'll give it as normally. Now, Q naught on A, where are you going? Q naught on A, you are going to Q1. Now, Q naught on B, do you have a transition? No. Q naught is having only on A, it is not having a transition on B. So this will be dash. Now, Q1 on A, we don't have a transition. Q1 on B, it is going to Q2. Now, Q2 on A, it's a self loop going back to itself. So it is Q2. Now, Q2 on B, again it is going to Q2. So this is how you are going to write a transition table. Now, any problem that is deterministic finite automata problem can be represented either in terms of a diagram or in terms of a table. This is called as transition diagram, and at the same time this is called as transition table. Two different ways of representing a deterministic finite automata. So in this class we have understood how you are going to define a deterministic finite automata and its 5 tuples, and after that we have seen an example and we need to define what are the 5 different things that we have in this finite automata. So in next class, we will see some of the basic problems on this particular deterministic finite automata. We will try to solve more and more problems on it. Thank you for watching.